So in this video, we're going to look at everything you need to know about surds to smash your GCSE exams. We're going to start off by looking at, well, what is a surd and what's not a surd? How do you multiply surds together? Then how do you simplify surds? Well, how do you prove things like that involving surds? How do you add and subtract surds? How do you express surds in a certain form? And these are quite popular exam questions like this. How do you expand surds, single and double brackets? And finally, how do you rationalize a surd? And what does rationalize even mean? And we look at many different examples. And as always, we'll wrap things up by looking at two real exam questions. And these are two different exam questions. And that's the whole point of this video, to build you up from the ground all the way to be able to smash exam questions on surds. And the way my videos work, I'm going to do the example on the left, which is I do. You're then going to press pause and have a go at the example on the right, which is you do. So you're not just going to sit there and watch. So work out the following. So we've got a square root with a number inside. So now 25, what two numbers multiply to give us 25? So that's going to be, well, if you do 5 times 5, you get 25. So the square root of 5 is essentially saying, what two numbers can I multiply together that are the same to get me 5? And you can see at the bottom here, I've got a table with them listed in. So for example, 1 squared is 1, 2 squared is 2, and in our case, 5 squared is 25. Now the next one's asking, well, what two numbers do I multiply together to give me 4? So that's going to be 2 times 2. So the answer here is 2. Now press pause and have a go at the example on the right. So hopefully the answer you got here is 3, and the answer you got here is 6. 6 times 6 gives us 36. Now moving on. So if you look at this one here, 100. So two numbers that multiply to give us 100 are 10 and 10. So the answer here is 10. However, if you come over to root 7, now with root 7, it doesn't have two numbers that are perfect squares. And what do I mean by perfect squares? So if you typed in root 7 on your calculator, you would get an answer of 2.6457. It doesn't have a perfect square, so you have to multiply. It's a really long number. You have to multiply this number by itself twice to get 7. So 7. So this is what we call a surd, when we have a number inside a square root that leads to an answer that's not a perfect square. So that's a surd. So you've got some examples on the left, right? So I want you to press pause and sort of circle the ones that you think are surds. So in the first case, 5 is a surd because it doesn't have a perfect square. 4, actually I shouldn't circle that. 4 is not a surd because 2 times 2 gives us 4. 1 is not a surd because 1 times 1 gives us a surd. 6 is a surd. There's no two whole numbers that we can multiply together. Two of the same whole numbers, I should say. Again, 4 is a surd. 16 is a surd because 4 times 4 is 16. And the same with 8. There's no two same numbers that we can multiply whole numbers to give us an 8. So moving on, now that we know what a surd is, with surds, when you have something like this in a square root and you're multiplying it together, it's just like normal multiplication. So 5 times 2 is 10, and then with the square root. So hopefully you've pressed pause and had a go at the example on the right. So that would be 6 times 5, which is 30, and inside a square root. And there's a rule here. So before we go into the rule, simply speaking, well, you know that root 9 is 3. You also know that root 9 here is 3. 3 times 3 gives you 9. And the answer to this is 9. Now, the answer to the second one, you can tell that without doing any work. It's 76. So if you notice the little pattern here, that number there is a 9. That number there is a 9. That number there is also a 9. And now this number here is 76. This number here is 76. And that number there is also 76. And there's a little rule with this. When you multiply two numbers, and it doesn't have to be a surd, when you multiply two of the same numbers with a square root, the answer is just that number. So press pause and have a go at the examples on the right. So since these are two of the same numbers inside a square root, the answer is just going to be the number. Again, two of the same numbers, that's just going to be that number. Now with this, it's squared, so it's essentially just saying that. So since we're multiplying two of the same numbers, the answer is just going to be the number. So here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. So moving on, well, how do you simplify something like root 20? So what you want to think of is, well, you can use this to help you down here. What two numbers can I multiply together to give me 20? And I'll come into a little bit of what the word simplify really means here. It's to put root 20 into a simpler form, and that form could have a surd or a square root still inside it. So if you think about two numbers that multiply to give us 20, so we have 1 and 20, but we never really use 1 because that won't simplify anything. So don't ever do anything with 1 here. The other one is 2 and 10. The other one is 4 and 5. Now, the reason this one is the most interesting is because it's got a square number in it, and 4 is a square number, and you'll see why. So if I now write root 4, root 5, I can simplify this further because this just becomes 2, and that's the answer here. So with the next one, it's the exact same thing. Now think of two numbers that multiply to give you 18, where one of them ideally is a square number, because that will allow us to simplify things. So that would be 9 times 2, so root 9 times root 2. Now root 9 becomes 3, we're left with the root 2. So now press pause and have a go at the examples on the right. So hopefully press pause now to go. So two numbers that multiply to give us 12, where one is a square number, would be 4 and 3. That simplifies to 2 root 3. Root 45, that would be root 9 and 5, where 9 simplifies to 3. And with this one, we have 3 times root 8. Okay, and then we can write 3 times. Now, root 8 can be simplified. The square, so that would be 4 times 2, because 4 is a square number. Now, root 4 just becomes 2. And 3 times 2 is 6, root 2. And I've purposefully not gone through this last example here with you because I also want to stretch you a little bit and get you thinking. So that's how you do that. Now, so as you can see at the top here, another way. So some of you might have thought, well, actually last time we did root 4 times root 5, which gave us 2 root 5. But what if we did root 2 times root 10? Could we get to the same answer? And yes, you could, but you've also always got to think about, can you get there? So with the root 2, we can't simplify that any further. So we leave that as root 2. With the root 10, we can simplify that to root 5 root 2. Now notice what's happened here, and I'll keep the time sign in the middle, that this and this match up. Now, if you remember the rule from earlier, when you multiply two square root numbers that are the same, it's the same as just the number, the result. So root 2 times root 2 becomes 2, and the root 5 can stay. Notice we got to the exact same answer. So moving down here to root 50, we can do, again, the quick way, if this comes to you, because it might not come to your mind. Some numbers are really big, and it might not immediately come to you. So if it immediately came to you, root 25 times 2, and that becomes 5 root 2. The other way you could do it is 5 times 10. Now, you've always got to think, can the 5 be simplified? This is how you need to start thinking. No, it can't. Can the 10 be simplified to a square number, to a factors where 1's a square number? No, it can't. So can we do something to help us reduce the 5? And yeah, well, we can do 5 times 2. And that's a root 5 already. These two become a 5, and that's a root 2. So you end up with the exact same answer. So now press pause and have a go at the examples on the right. So hopefully you press pause and have a go at this. Now you could sit there and of course think of a square number, or you could just go down the root 6, root 10. Now here again, you've got to think, can the 6 be simplified? Yes, it can. So that can become 3 root 2. And then can the 10 be simplified? Yep, that can become 5 root 2. Now notice this and this becomes a 2. So we can do 2. And then we've got root 3, root 5. Now, you don't want to leave it like this. You always want to tidy it up. When you're left with surds being multiplied like this, or square roots being multiplied like this, you always want to tidy it up. So that will become 2 root 15. So the quick way of doing this would have been root 4 root 15, which would have gotten you 2 root 15. Okay, but if that doesn't come to you, you can always come down this route. This is the whole reason why I've put this slide in, because a lot of teachers don't cover this. And with the bottom, it's a cubed. So we're doing root 14 times root 14 times root 14. Well, these two can be combined together. So that becomes a 14 times root 14. And now I have to think, can I break the 14 down into two factors where 1's a square number and 1's not? And if you think about it, the only two numbers that multiply to give 14 are going to be root 7 and root 2. But there's no need to do that because that doesn't help us simplify things further. So I can leave my final answer as that, or 14 root 14. It's the exact same thing. And here's one you want to watch out for. So I have wrote the word watch out because it might say simplify the following. Now, you might be tempted to write root 7, root 3, but that doesn't actually simplify it, because normally with the simplification, for example, if you end up with root 4, root 2, that does simplify. That then becomes root 2, right? But this isn't a simplification, and the actual answer to this question is that it it can't be simplified. So just watch out for that. So here's some practice questions for you to have a go at. Press pause and have a go. If you get stuck, rewind the video, watch the examples again. Here's the answers, mark your work. So moving on. So when you have something written like this, you can actually break it up. But you can do 3 times 25 times 3, which then gives you 125, and then simplify it down. Or you can actually break it up like this. You can do something like this, and then that gives us 5 root 3. Okay, so if you ever see anything written like this, you can always split it like this. So that'll be 16 times root 5, and 16 is 4 root 5. You see how much quicker that is? Had I multiplied this out, it would have given me root 125. Again, I'd get to the same answer, which is that there, but it'll just take a bit more work. So it's a bit quicker to do it like this, if you ever see anything written like this. So again, hopefully you've pressed pause and had a go at these, and that becomes root 4, root 3, which becomes 2 root 3. So looking at these ones now, so we've got root 20 and root 18. With these ones, you can tackle each bit on its own. So in this case, if you look at root 20, we can write that as root 4, root 5. And if you look at root 18, we can write that as root 9, root 2. I can simplify this down to 2 root 5. I can simplify the 9 down to 3 root 2. And now I'd like to write the numbers by themselves and the surds by themselves. So that'll be 2 times 3 times root 5 times root 2. And the 3 times 2 becomes a 6. And again, we can tidy this up. It can't be simplified any further. So that becomes 6 root 10. So looking at this one now, so we can break this down into 5 root 3 times 4 root 5. This can't actually be broken down any further, so let's just copy this down for now. That becomes 2 root 5, and you'd notice that and that. So that is going to be, again, if I write it out with the numbers on the left, I prefer writing it like this. It's just a little bit easier to follow. The numbers on the left and the surds on the right, that can tidy up. So that becomes 2 times 5 times root 3, which becomes 10 root 3. So again, hopefully you've pressed pause and had a go at the examples on the right. So that becomes 2, and then the root 6. So that becomes 2. These two combine together to give me the 6, which then becomes a 12. And then here, we have root 7 times 5, and that's root 7 times root 2. Now, there's no square numbers at all in this case. However, you can see that and that combined together. So that gives me 7 times root 5 times root 2. And we can tidy the final bit up because it can't be simplified. And that gives me 7 root 10. And with this one, it's, well, we've got a number in front of the surd, but the exact same thing applies. You can literally just imagine it's written with a time sign in between. So these two sort of become 3, and then you're left with 6. Again, hopefully you've pressed pause and had a good example on the right. So I prefer to write the numbers by themselves and then the surds by themselves, and then that becomes 7, that becomes 12, and then 12 times 7, and that's going to be 84. And then down here, we've got 2 times 2 times, again, I like to write the square roots on their own, so that becomes a 4. That leaves us that. The root 8 can be broken down into that, and then that becomes a 2, so that'll be 4 times 2 times, let's get the two them together, that becomes 8 times, that can combine together into a 2, which then becomes 16 as the final answer. So here we've been asked to show that the left side is equal to the right side. So we know the square symbol just means multiplying it by itself, 3 root 3. Now I like to write the numbers by themselves and the surds by themselves on the one side. It's just easier to follow. So 3 times 3 here gives me 9. Root 3 times root 3 gives me 3. 9, 18, 27. 27 is the answer here, and that's how you prove it. So this is where you actually get the working out marks. So you need to write all of this down. And again, hopefully you've pressed pause and had a go at the one on the right. So the numbers on their own on this side, and the roots on this side. So that becomes a 2, that becomes a 16, and 16 times 2 is 32. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, looking at addition. So the reason I've written 3x plus 2x at the top is because you can imagine it a bit like algebra. So if you were to add these two together, you'd get 5x. So similarly, you've got 3 root 5 plus 2 root 5, and that becomes 5 root 5. That's all there is to it. And it only adds together because they're both the same. If one was root 5 and one was root 6, you couldn't add it together. Similarly, you can't add x and y together. So just like that, you can't add 3 root 5 plus 2 root 6, right? That won't work. So again, hopefully you've pressed pause and had a go at the example on the right. So this is going to be x or 1x, however you write that. And this will just become root 2 or 1 root 2. Okay, it doesn't matter which one you write, but this is more common. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we've got this, and it's quite common for examiners to ask this actually, to express a surd in a specific form. So k root 3. If we have root 3 plus root 12. Now we can leave the first root 3 because it can't be broken down. And the second root 12 can be root 4 root 3. So that becomes root 3 plus 2 root 3. And then that becomes 3 root 3. So hopefully you can see why I just showed you how to add stuff together before moving on to this bit, because it all links in. And again, hopefully you've pressed pause and had a go at this one. So root 8 breaks down into root 4 root 2. 18 breaks down into root 9 root 2, which then becomes, well, that becomes a 2. That becomes a 3. And then if I add these two together, that is 5 root 2. And checking back to the answer, that's in that form, k root 2. So here's some practice questions for you to have a go at. And here are the answers. And now we're looking at expanding single brackets. So the way you expand single brackets is you take the bit outside, you multiply it by the first term. So that gives me 2 root 5. And then multiply that by that term. And that gives me root 2 root 3. And then that becomes 2 root 5 plus root 6 if we tidy that up. So the next bit, and you'll see, and you might be wondering why I did this and why I didn't just multiply it out, and you'll see why in this example here. So that becomes 4 root 2. I tend to write the numbers before the surds, and then the minus sign, and then that becomes 3 root 2 root 18. Now, I could multiply the 2 by the 18, but I tend to not want to make the number bigger if I don't have to. So that'll be root 2, 3 root 2. Now, the root 18 here can be broken down into root 9 root 2. So that's 4 root 2 minus 3. And that root 9 becomes a 3. And then we're left with the root 2 root 2. That combines together. So we have 4 root 2 minus 3 times 3, which is 9, times 2, which is 18. And then that becomes 4 root 2 minus 18. And again, hopefully you've pressed pause and know how to go at this example. So multiply the bit outside by the bits inside, and then that would become root 6 root 3. And can the 6 or the 3 be simplified? The 3 can't, and the 6, I can do root 3 root 2, yeah, that would help. So that would become root 3 root 2, and leave that root 3 outside. Now this and this combine together, so that gives me 2 root 6 plus 3 root 2, and this bit here. So now we've actually got a number in front of it as well. So we'll do 2 times 2, which is 4 root 7 minus, multiply that out, that'll be 3 times 2, which is 6, and then root 7 root 5. Now, the root 7, root 5 here can't be simplified, so we'll just tidy that up. And that can be root 35. So here's some practice questions again. Press pause and have a go. Here are the answers. Mark your work. And now we've got double brackets. So multiply the first term by the first term there. So that's 25. Multiply the first term by that, which is plus 5 root 3. Now multiply this first term by that. Remember the sign. So that's going to be minus root 3. And then now multiply it by that. That gives you minus root 3 root 3. So in terms of tidying this up, these two cancel out because that's plus 5 root 3 minus root 3. That becomes a 0. This becomes a 3. So we have 25 minus 3. And that then leaves me with 22. Now all this square symbol means here is we're just multiplying this by itself twice. So you can just write that out like that. Perfect. So 8 times 8 is 64. 8 times root 5, so that's minus root 5 minus 8 root 5 again. So I've just done that times that times that, and that times that, and now I'm going to do that times that. Now this bit you need to be careful in. So when you do root 5 times root 5, you've got to notice the sign in front of both. It's a negative, so that then becomes a positive. Root 5, root 5. So in terms of tidying things up, now that becomes a 5. These two, so that's minus 8 root 5 minus 8 root 5. So that becomes minus 16 root 5 plus 5. And that becomes 69 minus 16 root 5. So hopefully you pressed pause and had a correct example on the right. So that's going to be 4 times 5, which is 20. And then 4 times minus root 6. And then 5 root 2. Just make sure that looks like a 6. And then they're both negatives, so that becomes a positive root 2 root 6. So looking at this, what can we tidy up? So that can help us tidy up the 2, because so if we just write this out, 20 minus 4, here the root 6 won't do anything, so we don't need to break that down. Yeah, this is a really good example actually, because the root 6 here, let me just get my highlighter. The root 6 here won't actually do anything if you break it down, so we leave it as it is. However, if you break the root 6 down here, it actually helps us do something. Now, breaking the root 6 down here means this and this can be combined together. So that then becomes 2 root 3. So that's 20 minus 4 root 6 plus 5 root 2 plus 2 root 3. And let me just double check to make sure that looks. So that is that, that is that. That should have been negative. Awesome. So here's some practice questions for you to have a go at. Press pause and have a go. And here are the answers. And now we are going to look at, well, how can you deal with something like this? When you have a fraction inside a square root, let's say, you can actually break it down and you can write it like that. It's the same thing. And now you know root 4 is 2 and root 9 is 3. And same here, you can break that down. Root 3 over root 9 over root 16. So write the same thing out. And now you know that root 9 is 3 and root 16 is 4. So with this one, now there's 2 ways you can do this, and I'll show you firstly the way I prefer. So the root 12 becomes root 4 root 3. The bottom is just a root 3. We can cancel that and that out. That leaves you the root 4, and root 4 is equal to 2. So that's the first way of doing it. Now the second way of doing it is, because they both have a square root, we can actually write it out like this. And now 12 over 3 can actually be simplified. So 12 over 3 becomes 4, and then that gives you 2. I personally prefer doing it like this, but you can also do it the second way. So hopefully you've pressed pause and had a go at this example. So root 9, root 10, that gives me 90. That's root 10 there. That and that cancel out. That leaves me with root 9, which then becomes a 3. And if you did it the other way, you'd get the exact same answer. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, it says rationalize the denominator and simplify. What does rationalize mean? Now, rationalize simply means to get rid of the surd from the denominator. So if you multiply this by the denominator, so that's root 5 over root 5. And you might be wondering, well, why are we doing this? Now, remember I said to get rid of the surd from the denominator. What happens to the denominator if you notice now? That becomes a 5, the surd's gone. And that's why we do that. And this can be simplified because 5 times 4 is 20, so that becomes 4 root 5. So to rationalize this one, you just need the surd bit, you don't need the 3. So root 10 over root 10. And again, what's the point of doing this? Because that and that combine, so that leaves me with 3 times 10. And at the top, that becomes 4 root 5 root 10, which becomes 30 root 5. And the root 10 can be broken down into root 5 root 2. And these two can combine. So that gives me 4 times 5 root 2 over 20, which becomes over 30, sorry, which becomes 20 root 2 over, let's just say 2, there we go. And then that then becomes 2 over 3 root 2. So hopefully you've pressed pause and had a go at the example on the right. So we are going to rationalize the denominator, which means to get rid of the denominator. And the way we do that is we multiply the top and bottom by the surd. So that then gives us that, which is 10 root 2. And that root 2 times root 2 gives me 2, which becomes 5 root 2. And on this side, we just need the surd itself. So that at the bottom, this and this give me 6. So that'll be 2 times 6, which then becomes 12. And at the top, that gives me 5 root 2 root 6. Now at the bottom, I end up with a 12. At the top, I end up with a 5 root 2. But the root 6 can become a root 3 root 2. And these root 2's can combine together. So that then becomes 5 times 2 times root 3 all over 12, which becomes 10 root 3 over 12. And we can half that, so that's 5 over 6 root 3. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now it's going to get a little bit trickier, but not too much. So the exact same things apply now. So we've got root 5 over root 5. Step 1, get rid of the denominator. And that's the denominator gone. Now with this, it's like expanding the single brackets. So that'll be root 5 root 2 plus root 5. Now, if you can't simplify the 5 or 2, so we can just tidy that up. That'll be root 10 plus root 5 all over 5. So again, hopefully you've pressed pause and had a go at this. And that becomes 3 at the bottom, root 3 times root 3. And at the top, we are multiplying root 3 by 2, which is 2 root 3. And then we have root 7 root 3. Now the 7 can't be simplified, neither can the 3 on this side, so we can just tidy that up. So here's where things get a bit more interesting. We now have a number and a surd at the bottom, and they're being added together. Now what do we do? In this case, you change the sign in the middle, so that becomes root 2 over 1 minus root 2. Now again, the question might be, why do we do this? Notice what happens when we do this. Notice. So at the bottom, we now have 1 times 1, which gives me 1. Then I have, so I've done that. And now I'm going to do that, which is 1 times minus root 2, which is minus root 2. And then I'm going to do this. That is going to be plus root 2. And then finally, I'm going to do this, which is going to be minus root 2 times root 2, which becomes 2. And this bit here cancels out because that's just minus root 2 plus root 2. That becomes a 0. So essentially, we've gotten rid of, again, the surd from the denominator. But I'm going to carry on, do the top bit. So that's going to be 1 times 5, which is 5. And then 5 root 2. And if I go to the next line, that just becomes minus 1 underneath, 5 minus 5 root 2. And I can rewrite that as minus 5 plus 5 root 2. So again, hopefully you've pressed pause and had a go at the example on the right. So we are going to change the sign. So at the bottom, we have 5 times 5, which is 25. So that's that. And now we're going to do 5 times minus root 3. So that'll become 5 root 3. And now we're going to do root 3 times 5, and then root 3 times minus root 3. So that becomes plus 5 root 3, and then minus 3. Now again, this bit cancels out. So at the top we have 5 times 3, which is 30, minus 6 root 3. And then at the bottom, that leaves us with 22, 30 minus 6 root 3. And then we've got this. So it gets a little bit more trickier here because we just have more numbers being multiplied together, but the exact same concept applies. Change the sign, and the reason for changing the sign of the denominator is because it cancels out the surd. So in this case again, we are going to start off by multiplying the denominators, so that'll be 5 times 5, which is 25, and then 5 times minus root 3, which is minus 5 root 3, and now the other number, which is plus 5 root 3, and then minus 3. So this is similar to the last example actually, so that'll leave us with a 22 at the bottom, and at the top we'll have 8 times 5, which is 40, minus 8 root 3, plus 5 root 12, minus root 3 root 12. And actually I will multiply these two together here because I've just realized that becomes 36, and that'll just become 6, so that's nice and easy for us to do. So that's root 40 minus 8 root 3, and then we have 5 root 12, and I know 12 can be broken down into 4 root 2, and then minus 6. Now I can combine these two together, so that gives me 34 minus 8 root 3, and that now becomes plus, so that's going to become a 2. So that's going to be 5 times 2, which is 10 root 2 all over 22. And that is our final answer here. So hopefully you've pressed pause and had a go at the example on the right. Now, yes, you could have gone down the route of multiplying it by the opposite sign of the denominator. Now, another way you could do this is, well, you can see two numbers that can be broken down immediately, so that root 18 can be written as root 9 root 2, which then becomes 3 root 2, okay? And the root 8 can be written as root 4 root 2, which becomes 2 root 2. Now, I will say either way, however you did this question, you should get the same answer. So root 18 can now be written as 3 root 2 plus root 2, and then root 8 can be written as 2 root 2 minus root 2. Now, hopefully you can see that root 2 can be factored out at the top, and root 2 can be factored out at the bottom. Oh, sorry, that would then become 1. That would then become a 1. And now I can cancel the root 2 out, top and bottom. The square root's gone now, so you're left with 3 plus 1 at the top, 2 minus 1 at the bottom, and the final answer is 4. Either way, however you did this, you'd get the same answer. But what I want you to really notice here is the power of really looking at the question. Can you break things down right away that will make your life easier? And this is much easier than multiplying the top and bottom by the denominator, which will get you the same answer, but sometimes you can also think on your feet. So here are some practice questions for you to have a go at. And here are the answers. And finally, we're going to look at two real difficult exam questions to wrap things up. So at this point, feel free to press pause and have a go at both of these examples yourself, and then I'll go through them both. So starting with this one first. So we want this to be rewritten in the form a plus root 5 over b, and that is fine. Again, if we use the lessons that we just spoke about now, we can go ahead and write root 180 as root 18 root 10. We can break that down. It's a big number. Let's just break it down right away. And if you break this right down, you'd get your answer down to 6 root 5. So now I can rewrite this and say, well, actually, we have 6 root 5 minus 2 root 5 all over 5 root 5 minus 5. Now, unfortunately, I can't just factor out the root 5 because at the bottom we don't have it in the second term, so it's not as simple as the last example we did. So we are going to have to multiply the top and bottom here by 5 root 5 plus root 5 all over 5 root 5 plus root 5. And if I start with the bottom, so that would become, so if I do the first term, which is going to be that times that, that is going to be, I'll write it all out. So 5 times 5, and we've got the root 5 plus 5 times 5 root 5 minus 5 times 5 root 5. Let me just drag that over a little bit. Minus 25. And this can cancel out right away. And then at the top we have 6 times 5 root 5 root 5 plus 30 root 5 minus 10 root 5 root 5 minus 10 root 5. And I can tidy things up a little bit. So at the bottom we have 1, 2, 5, because that just becomes a 5 minus 25. And again, I can tidy that up a bit more, but I'll do it on the next step. And then at the top we have 30 times 5, because that tidies up. And then we have this, and this can be simplified down into plus 20 root 5, and then minus 10 times 5. And then that can be written as 150 plus 20 root 5 minus 50 all over 100. And then we can just take the 2 away, the 150 and the 50, and that's 100 plus 20 root 5 all over 100. And now we want to look at the question itself, and the question says you want it written in that form. So we can write this as 100 over 100 plus 20 root 5 over 100, which is getting there. And then the 100 over 100 can just be written as 1. The 20 and 10, so the zeros can cancel out, and that can be written as root 5 over 5, because the 2 and the 10 cancel down. So that is your final answer, 1 plus root 5 over 5. So the next one, again, I hope you've pressed pause and given this a shot yourself. So this one, I'll zoom in a bit because I think I'll need the space. So there's no big numbers right away, so there's no need for us to go and break any of the surds down. So that, all of it 4. Root 3, and with this one we will of course rationalize, I should say, the denominator, and we do the same with the other one. So I'll use some big brackets here. Minus 2 root 3 times root 3 over root 3. So I'll do the one on the right first because it's easier. So that's 2 root 3 over 3. So that's that one done. And the one on the left, so if we start with the top, it looks a little bit easier. So 12 root 3 plus 3 root 3 root 3. I'll leave the root 3's in just so you can see step by step what I'm doing. And at the bottom we have 16 plus 4 root 3 minus 4 root 3 minus 3. And that is that. So if you tidy the bottom up, that then becomes, well, these two cancel out, and that becomes 16 minus 3, which is just 13. So that's 12 root 3 plus 9, because them 3 combined, and that gives us a 3. So 3 times 3 minus 2 root 3 over 3. Right, and now we've got to multiply the top and bottom of this side by 3, because when you're subtracting fractions, you want to make the denominator the same. What this now does is it gives us a common denominator of 39. So we're going to multiply all of this by 3, 12 root 3 plus 9 minus 13 times 2, which is 26 root 3. And if we multiply all that out, that's 36 root 3 plus 27 minus 26 root 3 all over 39. And I can tidy that up, and I can write that as 10 root 3 plus 27 all over 39. So, and that is the end of the video. Thank you so much for watching, and as always, I'll catch you next.